the use of the construction with a digital camera and GPS receiver while researching dangerous areas. The purpose of the study is to select an effective method and equipment for observing deformations in dangerous areas of the terrain, such as areas that are undermined by underground mining. It is known that the topical task of the Mine Surveying Service is to improve remote sensing methods for the state of movement zones with grades, dips, and wrecks. The research technologies is based on the results of the performed analysis of methods for observing deformations using modern devices and technologies and experimental work using the development methodology which provides for the combined use of digital methods and GPS technologies. The modern photogrammetric methods are characterized by a high level of automation. Most of the operations that were previously performed by highly skilled performers can be performed by ordinary operators. Almost all software tools use ready-made processing templates. For example, Pix 4D has 3D maps, 3D models, e.g. multispectral templates. As a result of the automation and computerization most processes, some photogrammetric methods have changed significantly or disappeared altogether. In support of this, we can consider theodolite photography, which has now changed and uses handheld or tripod photography and is used to create overview with digital models and presentations, or is an addition to aerial photography from unmanned aerial vehicles. Phototheodolite photography, in the form in which it was used earlier, was much more accurate than aerial photography. A number of factors contributed to this. High binding accuracy of photographing station and images, close-up of the image, lack of blurring of the image, high resolution of photographic plates that were used for photographing. The presence of the referent devices made it possible to orient the camera relative to the photographing basis. With the use of modern technologies, when performing field work, the first factor that concerns the binding of photographing station still exists in the form of determine the point coordinates from which the survey is performed using standard autonomous GPS devices that can be installed on shooting cameras, for example on Canon EOS 6D camera, or using separate GPS modules that work through the camera's hot shoe, such as the GPE2 receiver. GPS devices of this class don't have the ability to receive differential corrections. On the territory that is located in the zone of disclaiming from the work of the Ordzhonikidze mine, the previous study was based on the results of aerial photography using the Sensefly drone with the following shooting parameters. The authors investigated the influence of the location of identification marks on the determining accuracy the spatial coordinates of the studied points. In the first case, all identification marks were included in the processing, and in the second only identification marks located along the outer contour of the site. Router mean square errors on identification marks are shown in the graph. The results on the analysis made is possible to exclude identification marks, the errors of which are more than 0.25 meters from the use of orienting images. For this, a design of the device was developed which allows determine the coordinates of the photographing station with an accuracy of 5 to 15 millimeters depending on the observing time, PDOP, and distance to the base. The device is designed on the basis of a Canon EOS 750D digital camera and a Topcon HIPER plus GNSS receiver. The design has an optical plummet which is attracted to a standard 3-pin tri-brace through an adapter. Thanks to this, the adapter can be easily removed and an electronic total station is installed in its place. The GNSS receiver is attached with 4 pins that allows you to adjust, decrease or increase the distance to the camera. The hole in the plate has a larger diameter than the bushing with allow the GNSS receiver to be accurately centered over the camera. With the help of this device, in May 2020, survey work was carried out from 6 stations, the distance between which was from 55 and 65 meters. The distance between the first and last photographing station was 230 meters, and the distance to the base was approximately 200 meters. The work investigates the research result of the influence of the determination accuracy of the focal length of a professional digital camera on the determination accuracy of the signal point position and their mutual position according to the digital model obtained from the survey results. In this case, the surveying was carried out without the use of recognition signs. If during surveying the coordinates of photographing station position are determined with the accuracy of 5 millimeters and the focal length is determined with an error of 1 millimeter, then one can expect an error in determination the position of the studied points in the range from 0.7 meters to 0.9 meters. With a rough determination of the coordinates of the photographing station position, for example, with an accuracy of 5 meters and with an error of 1 millimeters in the value of the focal length, the error in determine the position of the studied points can range from several to tens of meters. The proposed method was performing ground-based digital surveys with the coordination of photographing station using a GPS receiving instead of them, making it possible to increase the efficiency of monitoring the objects' deformations located in dangerous zones of rock movement and the ground surface. At the same time, the accuracy of determine the coordinates of the studied points without use of identification marks, which are necessary of orienting images, increases 10 times or more. It is clear that the proposed technique will also improve the accuracy of work in which identification marks are used to orient the images.